So now in this video, we're going to come back to this circuit that we covered in detail in the last video. What this does is it takes, in this case, a 5-volt power supply, and we can use these inductors to charge up a capacitor above 5 volts. So each square is 1 volt, working our way up. 8 volts is at the top there. So we can really easily get up to 8 volts. Now, the reason why it's discharging so fast is it's not storing a lot of energy. The oscilloscope has about 1,000,000 ohms of resistance between the probes. So this discharges kind of quick. But there we could see that we got above 8 volts when the power supply is providing 5 volts. So now down here we have 4 LEDs in series, but they're not lighting up. These are green LEDs. They're probably blocking at a minimum, this is a 220 ohm resistor, at a minimum about 2.5 volts approximately. So when it gets higher current, they start blocking about 3. As you can see, we don't even have 1 milliamp of current going when we light up 2 of them. And so when we light up one, we should have probably 7, 8, there we go, 7, 8 milliamps of current. So 5 volts is not enough to light these up while they are in series. So it's easier to move the LED than that jumper. So I'm going to move it up here so that we have them in series again, but away from that jumper. So what we're going to do is, with our voltage booster right here, again, this is a pretty simple voltage booster, and they sell these. So this is the negative side of the capacitor. They sell modules, voltage booster modules, which is what you would actually use. But it's still a pretty fun circuit, in my opinion, to make on your own, to be able to boost a voltage with inductors on your own. So now, when I hit the button a bunch of times, now you can start seeing it flash. So again, they're not flashing really bright. And also when I hit the button, you can see how much current we're putting through the inductors. So each one is passing about 0.05 amps, about 50 milliamps. And there you can see the LEDs are flashing. So we're getting up to probably about 10 volts right there before the LEDs flash. So now another thing, this capacitor can be charged up to 50 volts. And so potentially, if especially if this was more efficient of a circuit and whatnot, we could exceed that 50 volts. So having something like this, a semiconductor that starts conducting at a specific voltage, is one way that you may protect the capacitor from overcharging, from getting too much voltage. And also, let's get the oscilloscope. So we saw that the capacitor was quickly discharging through the oscilloscope before. And we'll make sure and top this off once the oscilloscope is on. So I'm going to quickly unplug that, and we don't need that LED anymore anyways. So we're going to put the red probe there, and black alligator clip right there. And it did already discharge. Alright, so what we're going to do is charge this up without the oscilloscope on there. And then we plug it in. You can see it was quite high right there. Let's change this to 5 volts A division. And hit this a bunch of times. I don't think we really have to risk getting to 50 volts with this setup, but again, you got to be careful. Okay, so we can see up there. So 5, 10, 15, 20. We easily got to 20 volts without the oscilloscope dragging it down. And we can do it one more time like that. So that's another thing the LEDs there did was, okay, it looks like we're topping out at about 20 volts, at least by the time it takes to get the oscilloscope on there. So the LEDs were limiting it to about 10 volts. So now I wired this up again. It's still 5 volts per division. We're looking at the voltage across the LEDs, which is also the voltage across the capacitor. So I got the jumper is going. But there you can see with 5 volts per division, we're only getting, looks like maybe 8 or 9 volts. And we can change the settings per division, so now each square is 2 volts. And you can see, yeah, it looks like we get little spikes to 9, but mostly it holds to 8. So that's because the LEDs are at very low current. They're probably only blocking about 2 volts. As current goes up, they block a little bit more voltage. But in any case, there you can see that we don't have to worry as long as we're not pumping so much current that the LEDs get damaged. They're going to hold the voltage to a maximum amount. So they're kind of acting like a Zener diode, kind of like a release valve in this case. So in any case, hopefully that all made sense and you enjoyed the circuit. I think it's a pretty cool circuit. Check out one of these other videos, click subscribe and the bell. I will see you in the next video.